the power term for the E, okay, and you assign this one to the theta, and then you do whatever you want for the theta. For example, you apply the Poisson or zip on the theta, maybe, okay. So here, okay, is another example we can use. Okay, this is a data set from the Institute for Digital Research and Education. By the way, do we have anyone here from maybe Professor Chen's lab, Chen Guodong's lab? No, not here. Or Professor Yang Zhenhua's lab? No. Okay. Because they are doing some research on education. So maybe this example is an interesting one for them. Okay. Unfortunately, we don't have anyone here in their lab. But anyway, so to exemplify a zip regression model implementation, we are going to use to work with a data set, okay, from this Institute for Digital Research and Education. Okay, so we have 250 groups of visitors to a park. So this is 250 groups of visitors, to a park. This is not exactly about the education, but this is the data set collected by a research and education institute. Okay, so here are some parts of the data per group. Okay, this is the following described like either feature or the count data. Okay, so first the number of fish they caught. Okay, obviously there are fish. Okay, in the river in this park. Okay, some park do not have a river. Okay, but in this case, that park must have some river. Okay, so the number of fish this group caught. Okay, and by the way, you may ask how do we calculate? Obtain such a value? But because in U.S. okay. This thing must be collected in U.S. because in U.S. you can buy license to catch fish, and the license allows you to collect a certain to catch a certain number of fish per year. So how many? No, you basically need to report how many fish you catch. Okay, every time you go fishing. Okay, because you don't want your fish license to exceed your limit. If you do that, you'll be fined terribly. Okay, so this is why in U.S. everyone okay if they go fishing they will report the number of fish they caught. Okay, so they have this information, number of fish they caught, and how many children were in the group. Okay, and whether they brought a camper to the park. The camper is not popular in Taiwan. Okay, camper is kind of like the type of car that you can live in the car. Okay, you can stay in the car for overnight. Okay, and obviously, for every camper, there's a kitchen that allows you to maybe you can once you catch a fish you can process it and cook it as a dinner. Okay, for everyone. Okay, so it's nice to have a camper, by the way, but obviously it's also very it's considered expensive. Okay, but in US if you buy a camper, obviously you can just park in your garage. But in Taiwan, I think maybe the price of camper is not that expensive compared with the price to park it. Okay, in Taiwan it's just crazy to park the car. Okay, anyway, okay, so using this data we are going to build a model that predict the number of caught fish as a function of the child and the camper variables. Okay, so we are going to use the second one and the third one as features to predict the first one. Okay, so we can use pandas to load the data. So fish data, okay, we just read CSV, okay. So this data set is called fish.csv, okay, which is provided by the book, okay. So you can explore data set using plots or pandas function, okay, such as, yeah. Well, I think it's let's take 10 minutes break. When we come back, we will continue our discussion here, okay? Hopefully we'll finish this example and also this chapter next hour, and then talk a little bit about the model comparison chapter, okay?